So we're going to start looking at rational functions. A rational function is a function that can be written in the form f of x equals a numerator function over a denominator function, where those functions are polynomials and the denominator is not equal to 0. So to find the domain of rational functions, it's going to be all real numbers except for the x values that make the denominator function equal to 0. So for example, if we were looking at the function f of x equals 4 over x minus 2 quantity cubed, we know that x minus 2 cubed cannot be equal to 0. So if we want to know about what specific x values would make this true, we can solve for this for x. So we would take the cubed root to get rid of the cube. What we do to one side, we do to both sides. So then we just have x minus 2 cannot be equal to 0, because cubed root of 0 is just 0. So x cannot be equal to 2. If x were equal to 2, then our denominator would be equal to 0. So our domain here is all real numbers except x equals 2. So we could say that our domain goes from negative infinity to 2, and from 2 to infinity. If we're looking at the function f of x equals 3x squared minus x plus 5 over x squared plus 1, again, we want to know what values are not in the domain of our function. So that's going to be any values that would make the denominator equal to 0. So if we take that denominator, x squared plus 1, we know that it cannot be equal to 0. So we could say that x squared cannot be equal to negative 1. We take the square root to get rid of the square. When we take the square root, it could be the positive or negative. So here we would get x cannot be equal to plus or minus the square root of negative 1. We know better is just I. Well, I is not a real number. I is an imaginary number. It's a purely complex number. So we don't have any real numbers that are going to make our denominator equal to 0. So here our domain is going to be the set of all real numbers from negative infinity to positive infinity.